Yeah, we'll go ahead and get started. So just a couple of quick introductions. So I am Alan Jen. I'm an associate professor in the Civil and Environmental Engineering Department, and I also am a researcher at the Institute of Transportation Studies, mainly pertaining to electric vehicles. And then we have our TA, David. Say hi to everyone over there, and our reader, Joey. And so they'll be able to provide some extra help in this class. Okay, and so let's talk about some quick course logistics. So all of the information that I'm about to tell you, it's all available on Canvas. The syllabus is there, and all the sort of general requirements, schedule, and expectations for the class are available online. Hopefully everyone's in the right place, right? Mondays, Wednesdays, 12 to 2, we'll be here. And then our only holiday for the quarter is on May 25th, Memorial Day. This is the schedule overview. I'm not going to go through this right now. Oh, all right. It's very distracting. Okay, and so this is a pretty interdisciplinary class. It's not just going to focus on engineering. We actually cover a multitude of different topics. We'll have a midterm exam halfway through, and then a final exam. I believe our scheduled date is the Monday after the first week, so that would be June 8th. Okay. And the schedule is set for the most part, but if folks have specific interests, I'm happy to kind of adjust the course a little bit. I may also make a few adjustments here and there, but for the most part, the schedule is going to be set. My office hours will be on Wednesday from 9 to 10 a.m. And then, David, are your office hours still going to be on Friday? Yep, right. And his office hours are going to be out in West Village, which is where our institute kind of sits. It's a little bit farther. Yeah, but hopefully that's not going to be an issue for most folks. Any questions so far? No? Okay. In terms of grading, we have quizzes. So we're going to have one every week on Mondays. Obviously not today. We'll have a total of 8 quizzes, and you guys can drop up to 2. Homeworks, we're going to have a total of 4 homeworks. They're going to be over the course of 2 weeks each, so they'll be assigned on a particular date, and then 2 weeks. Make sure to check the actual dates. It'll be approximately 2 weeks that you have to do them, and just a 5% deduction per day late. Midterm is going to be on April 29th during class. That's going to cover all the lecture material from 1 through 9. And then, as I mentioned, the final is going to be on June 8th. I believe our assigned time is 3:30, and the room is yet to be assigned. And that's going to cover all the lectures with emphasis on the second half of class. All right. Okay, AI usage policy. So actually, you guys are welcome to use AI. You can even use it in class if you want to fact check me. For homework assignments, I would strongly encourage you to try and do the work first without AI, and then you're welcome to kind of check the answers afterwards. Sometimes AI gets some stuff wrong, so just be aware that may be the case. Obviously, I can't police this, but what I will say is that the midterm and the final, a lot of the problems are going to be very similar to how the homework is set out, and we've typically found that if you're If you're just doing the work with AI, you tend to get lower grades on the midterm and final. So I'll kind of just have that as a warning and then let you guys navigate that yourselves. And then obviously you're responsible for verifying the accuracy of the AI responses. But yeah, I am not against the use of it. Just be sort of judicious and strategic about the way that you're using AI so that you can actually learn the material and make sure you do well on the tests. Any questions? All right. All right, so kind of jumping right in. Why do we care about electric vehicles? So I'll talk a little bit about kind of my personal motivations. When I was an undergrad, I was a molecular cell biology major, but I ended up taking a couple energy courses at my university, and I got really interested on the sort of energy and emissions side of things. And from there, we think a lot about the effects of greenhouse gases on leading to global warming and other climate change issues that are kind of harming our society. And the way that we address this, right, is to lower emissions to reduce the effects of those climate changes. And so one of the big ways of doing that is in the transportation sector, right? And so this is a pretty serious worldwide problem. We think about things like wildfires, increased extreme events, a lot of issues with sea level rising. This picture here is an image forecast of what may happen to Florida, for example. You can imagine that would be pretty bad, right? And so we think about, even from an economic perspective, how much damage that could be happening in different places in the US, to say nothing of the rest of the world. Yeah, and so that's a big motivating factor to think about trying to address emissions generally. And when we think about kind of the biggest contributors to emissions, so most of it is coming from the energy sector, and we consume energy in different ways. The middle pie chart here represents the amount of emissions coming from different sectors in the United States. It used to be the case, actually, that electricity was the biggest emitter, but actually there's been a big shift away from coal to natural gas, and that's actually led to a relative decrease in electricity emissions. And so transportation has been the #1 emitter for maybe the last 15 years or so. And the chart on the right gives kind of a breakdown within each of those sectors. The one in blue is in reference to transportation. And these are measuring slightly different things, so they're not going to line up exactly. And the biggest sort of bar you can see is passenger vehicles. And so that's really kind of the big motivating factor here, right? As we think about if you want to address kind of the biggest emission sector, at least in the United States, and the biggest chunk of that pie being in passenger vehicles, how do we get rid of emissions from passenger vehicles? One of the big solutions these days is thinking about electric vehicles. And so that's been probably one of the biggest driving factors for me to initially get interested in this field and kind of continue work here. But it's certainly not the only thing. I'm talking a lot about climate change emissions, but actually we can think of emissions in 2 broad categories, right? So greenhouse gases, those are the ones that actually affect climate, and then local air pollution, which affects health outcomes in sort of local areas. California famously has really poor air pollution, especially in southern and central California. There's just an enormous number of vehicles, and that leads to all sorts of bad health outcomes, increased rates of like asthma, lung disease, even cardiac diseases. And so this has been a big justification for vehicle emissions policies in California. And that's one area that we're going to talk a lot more about in sort of the end of this course. Okay, any questions? No. All right. And we will talk a little bit, kind of, it's difficult to talk about policy without getting into politics a little bit. And so electric vehicles, for some reason or other, have been dragged into kind of the political realm as well. And so there are those that are very passionate about this technology, and there's who are maybe a little bit less. And that's okay, right? So we're thinking about sort of the context of this technology across different political parties and what that means for electric vehicle support. So the current administration is pretty anti-electric vehicle. And so that raises a lot of kind of interesting questions of where the technology might go. But actually support for EVs, yeah, it may still continue. There are a lot of push even from the Republican Party to help defend some of the pushback against electric vehicles. And that's only in the US. One of the things that we'll think about is the sort of global competitiveness of the EV market, right? And so even if there is kind of a pushback in this country, what we're seeing internationally is leading to, yeah, a sort of diverging path for automakers in this country compared to what they're doing sort of internationally as well. Yeah, and it's not all political, right? So there are skeptics for this technology, even amongst some of the leaders in the automotive industry. So Toyota famously pushes back against a lot of electric vehicle policy. Their belief is that demand isn't there. And GM kind of flip-flops a lot. So there's this quote, "Electric vehicle is an idea whose time has come and gone. EVs are overhyped and under-deliver on expectations." I don't think anyone is kind of a oracle on any of this stuff. Well, I think it remains to be seen to what degree the technology will be adopted. But the one thing that I'll kind of mention is that this type of pushback is pretty common in any sort of transition to new technologies, right? And so back in the day, right, the horse is here to stay, but the automobile is only a novelty, a fad. And then there's no chance that the iPhone is going to get any significant market share. So, you know, these folks have made bad predictions in the past. And so we'll just kind of keep an open mind with this. Okay, and so when we think about why we care about electric vehicles, yeah, we can have a sort of multitude of different reasons and motivations. I hope many of you guys are here interested in this new technology. Maybe you're curious about what it's like to use an EV, how likely it is going to succeed in the new market. And so we'll learn all about that and a lot more throughout the course. Okay, any questions so far? All right. So, moving on. So, going to start with a couple of foundational basics for today. A lot of this material is, maybe it's review for some folks, but we're going to be talking in certain units that are very common to think about with electric vehicles. And so I want to make sure our foundation for this stuff is well developed. And so we're going to start off by talking about energy and power. So energy is the ability to perform work, either moving something or heating an object. There are many different forms of energy, right? So we think about kinetic, chemical, heat, electrical, electromagnetic, elastic, nuclear, and gravitational. Obviously, we're not going to deal with all of these in the course. The probably first four are going to be the most common forms of energy that we're going to talk about in this class. But just know that there are many different forms of energy, and you can go kind of in between them. There's always going to be losses, right? So law of thermodynamics as you move between different forms of energy. And we're going to think about how that pertains to electric vehicles as well as maybe more traditional vehicles as well. Okay, so the way that we measure energy is in units of joules. That's the international standard for energy, and that's used across a wide variety of applications and fields. So the definition of a joule is based on its ability to move a certain amount of mass or to heat a certain amount of water, right? So 1 gram of water by about 1/4 of a degree Celsius, or to move 1 kilogram, a distance of 1 meter at 1 meter per second squared. Okay, and so hopefully this is review for some. But actually, when we think about energy in this class, we're usually going to be thinking about it in terms of electricity. And that's going to be a little bit different. So energy is also measured usually in electricity in a form called a kilowatt hour. So again, most commonly used in electricity. And this is the amount of energy used at a constant power rate over some period of time. So we'll talk about power, and maybe we'll skip forward. We'll talk about. I'm going to come back to this. So power is the rate at which you do work, energy over time, and our main units of power are watts or horsepower. So watts, the SI unit for power is 1 watt, which is a joule per second. Commonly used in electricity to describe, let's say, the capacity of something that produces electricity. So if I had like a power plant that had an installed capacity of 10 megawatts, it means I can produce 10 megawatts of power instantaneously. So conversely, if I have, let's say, an LED light bulb that was rated at like 5 watts, that means if you turn it on, you're using 5 watts of power continuously. Okay. And jumping back to our kilowatt hour discussion, this is an easy way for us to determine how much energy is used over some amount of time, because you can just multiply your power output by that amount of time. So let's see. So who can tell me why 1 watt hour is equal to 3.6 kilojoules. Anyone have any idea? Yes. Sorry, you're going to have to speak up a little. Yep. Yeah, exactly. So remember, a watt is 1 joule per second. In an hour, you have 3,600 seconds. So it's basically 1 watt times 1 hour. You're canceling out the seconds units by 3,600 seconds per hour. And that will translate to 3,600 joules or 3.6 kilojoules. So if I were to have that 5 watt LED light bulb that I was just talking about, and I wanted to understand, how much energy does it use over the course of an hour? What would that be in watt hours? Any ideas? So I have a 5 watt light bulb on for 1 hour. Yes. Yep, it would just be 5 watt hours, right? So that's why we do this in watt hours or kilowatt hours. It's kind of an easy way to translate from the power to the amount of energy consumed for some unit of time, right? You could convert it to joules, in which case it would be 5 times 3.6, right? But most of the time we'll be working in these sort of electricity units. Any questions about that? All right. So the other unit of power that's commonly used in automobiles, I'm sure you guys have all heard of this, horsepower. Yeah, so commonly used to describe power for engines and mechanical power. There is a rough translation of what this equates to. So you're supposed to be able to lift 75 kilograms, 1 meter in 1 second. There's actually 2 units of this, one in imperial, which is equal to 745.7 watts, and one in metric, which is close but not quite the same, 735.5. You won't need to memorize this or anything, just kind of a interesting tidbit. Does anyone know actually where horsepower comes from? Does anyone know how much power a horse can produce? Any guesses? Yeah.
About 2 to 3, but up to 5 to 6 when they're really running.
Yeah, actually a little bit more. Peak power production, if they're really going, is like 15 horsepower. So it doesn't actually pertain to necessarily the amount of power a horse produces. It's actually coming out of like average power of a horse. So it's more than one. All right. So where does this come into play when we talk about vehicles? Okay, and so we think about this energy in terms of the sort of energy content that actually translates into ultimately mechanical energy to move your vehicle, right? And so for a standard vehicle, for a gas car, right, we actually think about just the quantity of energy contained in the gasoline, right? And so, a Toyota Camry has about a 16-gallon tank of gas, and that can go some amount of distance on average. And the analog of this for electric vehicles is going to be slightly different, right? So here, we still care about range, but obviously there isn't a tank of gas in that vehicle. Instead, that energy is contained in a battery, in the form of essentially stored electricity, Okay, and the energy content of that electricity we measure in these units of kilowatt hours. Okay, and so you can see from this figure, right, you have a couple of different models of vehicles that can have different sizes of batteries, right? That's essentially saying, oh, we have slightly different sizes of our gas tanks, right, that contain the energy that will translate into moving the vehicle. So Tesla Model Y has a 75 kilowatt hour battery. The Mustang Mach-E has a 68 kilowatt hour battery. There's actually an extended range one, which has 91. Chevy Bolt has 60, and the Nissan Leaf has a 40 kilowatt hour battery, or the old one at least. The new ones I think are at 60 kilowatt hours. Okay, and so for a gas car, we can think about how efficient a vehicle is, right, by seeing how far that gallon of gas can get you, right? So if I take the mileage and I divide by the gasoline amount, you get something like 34 miles per gallon. So I think that's a unit that most people are familiar with. And on the electric vehicle side, we similarly can get an aspect of the vehicle's efficiency by doing that kind of division as well. Here you see that actually there's two numbers. So the first number, I say miles per kilowatt hour. That's done kind of in the same way as MPG. And so these numbers are hopefully things that you guys will get familiar with as we build up context and discussion around efficiencies in general. So generally we're talking about something on the order of like 2.5 miles per kilowatt hour for like a much less efficient vehicle, up to as high as like 4 to 5 miles per kilowatt hour for more efficient electric vehicles. I also have it in reverse. So you'll see that there's this 0.25 kilowatt hours per mile, for example, for the Tesla. And that's just the inverse of that ratio. And I'll talk a little bit more about why we think about it in these two ways. It turns out that MPG isn't the most intuitive unit to use to think about efficiency. We'll talk about why that is a little bit later on in this class. Does anyone actually know what the rest of the world uses outside of the US in terms of efficiency? Because it's not MPG. Any ideas? Yeah.
I think it's not math. Like, no, I don't know. I don't know. Actually, sorry.
Yeah. Well, first of all, most of the rest of the world doesn't use miles, and most of the rest of the world doesn't use gallons. So they do kilometers and liters, but that's not the important part. Actually, the important thing is they do the reverse. So we do miles in the numerator and gallons in the denominator. Most of the rest of the world does liters, right, the volume in the numerator, and kilometers in the denominator. And so, switching to electric vehicles, it's like kind of a chance for us to like fix that, although at this point, a lot of people are sticking with miles per kilowatt hour. But anyways, I put both numbers because I think it's important to kind of keep that concept in mind. And again, we'll explore during our efficiency lecture why that's important. Okay, any questions about any of this? Okay, yeah, and so again, this stuff, we're building up our sort of basics, and hopefully, I think most people have a decent grasp of like MPG. If I were to give you an MPG, if I'm saying like 15 to 20, hopefully you guys can associate that with being maybe a less fuel efficient vehicle, maybe an efficiency that's more associated with like a truck or a van. versus if I'm saying like 50 to 55 mpg, you're like, oh, that's a pretty efficient car. That's probably something like a Prius or some kind of efficient hybrid, right? So we just want to build that kind of intuition for efficiencies for electric vehicles as well, right? So if you're talking about like 4+ miles per kilowatt hour, you're probably talking about a fairly efficient electric vehicle. Okay, and where does the power part of it come in? And this is where I think it makes the math a little bit easier when we're thinking about things in terms of like kilowatts and kilowatt hours. So if you have like a 75 kilowatt hour battery, that might be something like 300-ish miles. For us, where power becomes a lot more prevalent in our sort of discussions of EVs is thinking about when we charge an electric vehicle. Okay, and so who's ever charged an EV before? A couple people? Okay, yeah, we get slightly more and more every year, but yeah, we'll take a lot more detailed view of this later as well. But unlike a gas station, where you go to a gas station, you fill up in 5 minutes, that's all well and good. The sort of environment for charging an electric vehicle is going to be slightly different. You charge at different speeds. Okay, and so they kind of classify this in 3 broad categories: level 1, level 2, and then DC fast charging. And I break that out into a little bit more categories. But level 1 is basically just your normal like wall outlet. Okay, you could actually charge a car just plugging into a normal wall outlet, but it would take a really long time. So level 1 charges at a power rate of about 1 kilowatt. Okay, and so if I had a electric vehicle with 75 kilowatt hours that was completely empty, and then I wanted to charge it using level 1, right, how long would that take? It would just be 75 kilowatt hours divided by 1 kilowatt, so about 75 hours, right? Level 2 is at a higher voltage, and so you can send more power. So typically you're between like 6 to 20 kilowatts. So we'll say if you're charging at like 7 kilowatts, that would take about 10 hours. And then DC fast charging, there's different rates in this like broad category, anywhere from 50 kilowatts all the way up to 350. And you can see that, right, as I charge faster and faster, it takes me sort of less time to charge up the battery, right? So 50 kilowatts, that might be something like 1.5 hours. All the way up to 270 kilowatts, that might be something more like 15 minutes. And we'll talk in a lot more detail about charging a little bit later on. This simplification is, yeah, it's a pretty rough simplification. Actually, there are some nuances that make this a little bit different from just filling up a gas car. And so we'll want to keep that in mind. Okay, any questions about charging? Okay, so the last thing that I'm going to cover today, some basics about the sort of general architecture of electric vehicles, especially in comparison to other types of technologies. Okay, so I think it's important to kind of distinguish the characteristics of electric vehicles from current technologies. And so we're still going to do a little bit of an overview of how sort of current vehicles work as well. So in an internal combustion engine vehicle, the drivetrain is powered by combustion of fuel, right? And so essentially what you're doing is you're taking gasoline or diesel, you are injecting it into a chamber where it combusts, that moves the piston, and that is where we translate from chemical energy into heat and mechanical energy. A lot of that, a lot of the energy is essentially lost in heat. Okay, we don't actually lose energy, right? But the useful energy that we can extract from it, it's only about a fifth of the useful energy out of gasoline. The rest goes into heat. And then we take that and we translate that into mechanical energy, right? So that's in the engine, you have pistons that move up and down. That translates all the way through your drivetrain into actually spinning the wheels of the vehicle. There's a lot of moving parts in an engine, right? You have your pistons, you have your crankshaft and your camshaft. That all goes into the transmission, into the drive shaft that ultimately turns the wheels. So many moving parts. And that's often why you have a lot more sort of need for mechanical repair in a combustion engine vehicle compared to some of the newer sort of electric vehicle technologies. And these typically, again, consume gasoline or diesel. Gasoline is often blended with ethanol, and so you're not getting sort of pure gasoline when you're filling up at a gas station. Yeah, and actually, so there's a whole sort of separate discussion about the use of alternative fuels in gasoline. Right now, we typically have about 10% of ethanol blended in. In California, it's a little bit higher at 15%, but actually because of the recent war in Iran, the president actually authorized higher amounts of ethanol to be blended in with gasoline, which helps to reduce some of the demand on gasoline and can relieve some of the pricing pressure, but not much. Yeah, that's another sort of maybe benefits of electric vehicles. We have found in all the research that happens that typically when gas prices are a lot higher, that sales of electric vehicles tends to increase as well. No surprise. And I guess that can be happening in recent days as well. Right, I don't know what gas prices are right now, but I'm sure they're higher than average. Okay, any questions or comments? Okay. So I wanted to also kind of help kind of reduce some confusion sometimes about nomenclature. This is a very common area of confusion. So HEVs are hybrid electric vehicles, but not to be confused with, in general, the electric vehicles that we are talking about in this class. So even though it's called a hybrid electric vehicle, what I would say is that you should be considering hybrid vehicles as essentially gasoline vehicles. So they're primarily internal combustion engine vehicles and are not considered to be really true electric vehicles. And the reason for that is the drivetrain. In other words, the whole sort of mechanism of actually spinning the wheels on your car is primarily powered by gasoline and diesel, right? So it is powered through an engine that is combusting some fossil fuels. The reason why they call it a hybrid is it has sets of features that help improve fuel efficiency. Probably the most prominent ones are regenerative braking, which is when I hit the brakes on the car, normally, right, in a typical vehicle, all of the energy from motion is getting translated back into heat, and you just lose that energy. Whereas in a hybrid vehicle, you get regenerative braking, which means that the energy, and we'll talk about the process with which this happens, but the energy is essentially stored back into some kind of battery that can help to assist the vehicle in propulsion. And so you get a lot of energy back from regenerative braking. There are also things like start-stop systems where you can reduce idling by shutting the vehicle off when you're idling. And so if you think about a car that goes, that's driving around in the city, if you stop at a stoplight or you stop at a stop sign, some cars, the engine will actually turn off. That's a common feature that was first introduced in hybrid vehicles. But actually, you can find that in even non-hybrids these days. And of course, the definitions get muddled a little bit. Some hybrid vehicles will actually allow you to drive just on the battery. So like the Prius, for example, in the last like 5 or 6 years, the batteries are kind of big enough where they let you drive just on the battery for up to like 3 or 4 miles if you're going under like 30 miles per hour. But that's a feature of hybrids that is a little bit newer, and that does muddle the definition a little bit, but for the most part, right, most of the driving that you're doing, like the vast majority, 90+%, is gonna be on gas. Any questions? Okay, and so all of that having been said, this is mainly, again, to sort of distinguish that HEVs are not traditionally going to be considered electric vehicles that we're going to be interested in. Okay, 2 other terms that are kind of common in this domain are electric vehicle and plug-in electric vehicle. So an electric vehicle is simply a vehicle where that drivetrain propulsion is powered by electricity rather than combustion of fuel. And the most common one that we think of is probably the electric vehicle that you guys are familiar with and thinking about, right, where you have a battery that powers that drivetrain. But electric vehicles actually also encompass a category of fuel cell vehicles where you might have some kind of different fuel going through a fuel cell to produce electricity that then propels the vehicle. Okay, and so EVs contain both electric vehicles and fuel cell vehicles. Plug-in electric vehicles are a subset of electric vehicles where it's only the ones that are charged by plugging in your car to a charger and then using those batteries to provide storage for the energy to propel your vehicle. So all PEVs are EVs, but not all EVs are PEVs. Okay? Okay. PEVs are going to be broken down into 2 further categories. So one is battery electric vehicle. And so this is the sort of more typical one that we think of, where the drivetrain is fully powered by a battery. It operates entirely on electricity that's powered solely by that onboard battery. The battery powers a motor to translate electricity into motion. And so essentially what's happening is you have a motor that's connected to the battery. You have electricity going from the battery to power the motor to essentially power the drive shaft and spin the wheels, right? And so in comparison to what I was mentioning before with a gas car, you know, your engine has all of these moving parts. Really the only moving part here is just the motor. You may not even have much of a sort of transmission system within the electric vehicle. And that's an important distinction that we'll talk about either next lecture or the lecture afterwards. All right. And the other, so I was mentioning with PEVs, we have these two categories. The other category, right, besides BEV is the PHEV, which is a plug-in hybrid electric vehicle. So this is a vehicle that contains the drivetrain of both an internal combustion engine vehicle and a BEV. So not to be confused with our conventional hybrid electric vehicle, right? Which only is powered by, going to a gas station and pumping gas. With a plug-in hybrid electric vehicle, you actually have both a big battery as well as a gasoline tank. And that means this vehicle has both a motor as well as a battery. So plug-in hybrids can actually operate solely on electricity, right? And so it won't be turning on the engine at all. It'll just be using the battery and the motor and operating just on electricity. But it can also turn on the engine and operate on the engine as well. And we'll talk about sort of different configurations of plug-in hybrids later on. And depending on the configuration of the vehicle, the operation will be a little bit different. So there's parallel series, and we'll talk about what those mean a little bit later. So why do we have plug-in hybrid vehicles? What do you guys think? Any ideas of why the industry would go with some companies thinking about pure battery electric vehicles and some companies thinking about having plug-in hybrids? Yeah. Yeah, exactly. So one of the big sort of common concerns amongst the sort of like broader consumer base is this idea that like, oh, electric vehicles have like a shorter range, or they take a really long time to charge, or a combination of the two, right? And so plug-in hybrids were introduced as kind of a solution to both, where if I needed to fill up quickly, I could do that, and you wouldn't have to worry about the range because you could always switch from the battery to the gas vehicle. Okay, and so you can imagine that if I have both systems in the car, these ones tend to be the most complex. You also don't have the space to put in the kind of full-size battery that you might expect in a BEV. So the all-electric range of plug-in hybrids tends to be quite a bit lower than that of a full battery electric vehicle. I think the most common plug-in hybrid is the Prius Prime. That one used to have a range of like 25 miles. I think it's now up to 35 or 40 miles. And so you might think, oh, okay, well, that range seems very low, which is fair. But the one thing I'll say is that the average American drives around 30, 35 miles a day. And so if you think about it that way, then most of the trips that you would be making, you could operate on electricity, and then you could use the gas portion of it just on like a long trip, for example. And so the plug-in hybrid is kind of compelling for some folks who are worried about some of the sort of traditional drawbacks of battery electric vehicles. Although I will say that, yeah, the PHEV, it avoids some of the problems that you might have with the full BEV, but it comes with its own sort of set of drawbacks, which we'll talk about later as well. So backing out of the category of PEVs to talk about the broader category of full electric vehicles, we have fuel cell vehicles. So FCVs employ some kind of fuel cell to oxidize a fuel to generate electricity. The most common one is the hydrogen fuel cell. That's really the only other sort of commercial option, although it's not even broadly available. From a technology standpoint, right, the way this works is you essentially send in streams of hydrogen and oxygen. Usually the oxygen is coming from air. Those will combine in the fuel cell, and that's going to essentially create electricity that you need to actually power the motors. A lot of modern fuel cell vehicles, hydrogen fuel cell vehicles, also have a battery that gives it the ability to do a lot of the technology improvements and benefits that we saw in the hybrid vehicles, and so things like regenerative braking. But actually most of the drivetrain power is going to be coming from the stream of hydrogen converting into electricity. Okay? So fuel cell vehicles, we will talk a little bit about them, but not so much in this course. The main focus is going to be on plug-in electric vehicles. Okay, the last thing, sort of broad category that I'll reference is with a zero emission vehicle. This is vehicle that has no tailpipe emissions. A lot of the reasoning behind this particular category comes down to specific policies that are looking to promote certain sets of vehicles. And so the actual definition of a zero emission vehicle can actually change a little bit depending on the context that you're looking at it. But in general, we're thinking essentially about a vehicle that doesn't have emissions, right? So that's easy enough for battery electric vehicles and for fuel cell vehicles, right? So with a full battery electric vehicle, there's no emissions, right? You simply have electricity coming out of the battery. And with a fuel cell vehicle, you don't have, so technically you don't have really gaseous emissions. There is a byproduct with hydrogen vehicles. Does anyone know what that byproduct is? Yeah.
Water.
Yeah, it's just water. Right, so hydrogen and oxygen will combine to form water. That's an exothermic reaction to help generate that energy, and then you're left with water as a byproduct. A lot of modern day fuel cell vehicles, you like press the button and it will squirt out the water that's built up in the fuel cell. But yeah, so BEVs and FCVs are definitely sort of broadly considered to be zero emission vehicles. But not all electric vehicles and plug-in electric vehicles are zero emission because, for example, a plug-in hybrid electric vehicle does have a tailpipe and it can have emissions if you're operating on the gas part of it. So it's not a pure zero emission vehicle. Okay? Any questions about that? Or anything so far? All right. So kind of to sum up, yeah, our general classifications look something like this. So our traditional vehicles, internal combustion engine vehicles on the left. So all the cars that you most prominently see out there are probably going to be gas cars of some kind. And then a subset of those vehicles could be hybrids, right? So think of like the Toyota Prius as the most common example. And then on the right-hand side, we're thinking about electric vehicles, of which you have plug-in vehicles and then your fuel cell vehicles. And within the plug-in vehicles, you have BEVs and PHEVs. And most of the class is going to be centered around PEVs in general. We'll talk a little bit about fuel cells here and there, but the focus is going to be on those top categories. Okay. Yeah, and so the one thing that I'll mention is some of these definitions are a little bit blurry, and again, depending on the context, particularly in policy, the way that we classify certain vehicles for regulatory purposes may be a little bit different, and we'll revisit this towards the end of class. But in general, I would say. Yeah, the sort of broad categorization can fall into these classifications. All right. So I'm gonna. So I have this slide just for kind of nomenclature as a reference. This is kind of just reiterating what I was going through with all the classifications. And so feel free to kind of reference this as kind of a summation of the last couple slides that we were talking about. Okay, and so that's actually it for today. This is the kind of only lecture where I end a little bit earlier. Couple quick notes is that all of the slides are going to be posted on Canvas after class, and so you can go back and reference those notes as needed. And then I also record the lectures, so if you wanted to go back and review anything on video, or if you missed class, you're welcome to look that up. The videos will be posted both on Canvas and also my YouTube channel. I have class recordings. So other than that, we'll see you guys all on Wednesday. And I'll stick around if anyone has any questions. Yeah. Yeah. So actually,